Good afternoon.
Good afternoon, doctor.
Yeah, good afternoon, sir.
Good afternoon.
Good afternoon, doctor.
So we have with us Dr. Asi. Uh, oh, the network. Yeah, that's great. So very good afternoon.
Good afternoon to you all.
Yeah. So let me introduce our today's speaker and the trainer and the able person who can just take us around this impact and all about the climate change. So I really thanks to Dr. Asi because she accepted my proposal in one day. So very short notice. So I will really thank for your gesture to us and sharing your knowledge with our team. So I want to just introduce all of you with Dr. Asi. Dr. Asi is done her PhD from Netherlands, and she work on a modeling like a nutrient flow and balance in agro ecosystem. And she got a research grant from International Foundation of a Science, and she was the visiting scientist in U.S. University, and this is work for a farming system and research in Jaria University, and she's a member of a different scientific bodies. And currently, she is working with the Environmental Science and Physics Department of Zaria University, where she is working on soil, plant, and water relation with agroecological system. So, thank you very much, Dr. Asi. And yeah, we have just little introduction about our aim, because Indorama is engaged in fertilizer production. We are producing 4,000 tons per day urea, and we are distributing this urea all across Nigeria, plus some of the Western countries, as well as exporting to some South American countries. Apart from this business, we want to take an approach of an inclusive growth. So we have a 56 agronomists working across the Nigeria, as well as different parts of Western Africa, and the effort is to deliver our knowledge and services to the farmer and take this Nigerian agriculture to a next level. So in that context, you are sure, means you know that building in-house capability is really important, and that's how we requested you for sharing your experiences and knowledge and expertise around the climatic change, and specifically its impact on a crop management and how to handle that. So, with those words, I'll just pass on this stage to you, Dr. Aisha. Sorry, not Asi, Aisha. So, over to you. Thank you.
Okay. Good afternoon to you. I hope we are all in the afternoon, and I hope you can all hear me. I hope you can. Can you all hear me?
Yeah, we can.
Yes,
Okay.
Yes, Prof. Can hear you.
Okay, that's very good. That's very good. So I'm going to share my screen here. I hope that we will have a very good okay. Okay, this afternoon we are going to see some things on climate change and how to efficiently manage the impact of climate change in crop production. And I'm sure we all know that, I hope you can all see my screen.
Yes, we can.
Yes, ma'am.
Okay, okay. I hope also to remove the annotations. Let me go to more. Disable annotations. Good. All right. So here, I just want to say that the climate is changing. We all know that. And climatic variables mostly that are being looked at are mainly the temperatures and the rainfalls and how it affects or impacts on the agricultural production. So measurements have shown that averaged over the globe, the Earth's surface had warmed since the 1850s. And this warming has not been gradual. Instead, it has been largely concentrated in two periods. These two periods mainly from around 1910 to around 1975 to around 2000. So since then, the warming trend has continued. And we have seen that in areas in the Arctic, the Arctic is melting, and it has led to the rising of the sea levels. And in other places that are getting warmer, we also notice that the temperatures are getting warmer in the drier areas, and around 0.15 degrees centigrade warmer than the decades in the 1990 to 1999. So global temperatures also in 2016 to 2020 has been shown to be warmer by 1.1 degrees centigrade compared to the periods of the 1950 to 1900s. And this is by the World Meteorological Organization. And also in terms of anthropogenic emissions or sectors that contribute to global warming is the AFOLU sector, which is short for agriculture and land use changes. And this sector globally contributes 23% of total global emissions, according to IPCC AR5 group. So high income countries have also been shown to have higher emissions, which leads to this global warming and resultant climate change, while low and lower middle income countries release greenhouse gases mostly in the AFOLU sectors. So now what's the implication for this climate change? I've mentioned earlier that it causes rising in sea levels, and their impacts are extreme weather and climate events, where we see incidences of flooding or incidences of hurricanes, and sometimes you even see incidences of forest fires. These are all extreme weather events that are being experienced. Then there is also a clear fingerprint that most of these changes or impacts are being caused from human activities. When we say human activities, like anthropogenic activities, and we saw that it was mostly during the evolutions of intensification in cropping systems, and then the industrialization era, that you see that these greenhouse gas emissions were increased in the atmosphere, and they caused the global warming effect. So let's now look at our own peculiarity, which is Nigeria. In Nigeria, the mean air temperature is between 1901 and 2005 was 26.6 degrees centigrade, while the temperature increase for the whole period was 1.1 degrees. So you can see it's also close to the global trend. And this is obviously higher than the global mean temperatures of 0.8 degrees, which was recorded from 1850, when the actual scientific temperature measurement started. So we can see in Nigeria, the temperature increase is even higher than that of the global average that is being projected. And if this trend continues on, then we may experience between 2.5 degrees centigrade, which is in the middle risk, and the 4.5 degrees centigrade risk in temperature increase by the year to 100. So these also have big implications on our agricultural systems, and a sea level rise of 1 meter could result in the loss of 75% of the Niger Delta area of this country. So this is supposed to be taken very seriously. And when we also look at the rainfall, within this 105 periods that is previously mentioned, the rainfall amount in Nigeria dropped by 81 millimeters. This is just the general across the country. Although the general decrease in rainfall in Nigeria was experienced, but in the coastal areas like Warri, Brass, and
Aisha
Calabar.
Abdulkadir, see our lecturer, Freddie.
Yes, can you, hello, please, can you mute yourself? Can you mute yourselves? So around those areas, we observed that we are experiencing increasing rainfall in recent times. And not only in these areas, in the northern part of the country, you see that increasing flood events are occurring. We have this kind of extreme weathers where you have flash floods. It's not all the time, but you have very intensive rainfall events that will lead to flash floods. And this is clear evidence of climate change, because a notable impact of the climate change is increasing rainfall in most of the coastal areas. And then you also see a decreasing rain in the continental interiors, like where you have the savannas or in the semi-arid areas, where you have decreasing rainfall events as well as increase in temperatures. So let us just look at this graph quickly. You can see in the 1963, this is just an evidence that the climate is changing as it impacted in the shrinking of the Lake Chad region, that currently just 5% of its size is extinct from what is observed in 1960. So you can see in 1963, the Lake Chad is almost all water here, blue. But as time goes on, 1973, 1987, 1997, and 2001, you can see the extent of the shrinkage of the Lake Chad basin, and this has been attributed mainly to the changing climate. So this climate change also impacted on the agricultural sector in Nigeria. So to give you a very brief background, the agricultural land in Nigeria constitutes 78% of the total land mass of the country. Amongst this, I think 48% is under arable crop production, while 9% is under permanent crop and crops like the perennials. And then the 43% approximately is under pastures or meadows, and you have these shrubs. So and agriculture is very important to the country's GDP, because in the past, in the 90s, 80s, 90s, it contributes even more than 40% of the country's GDP, while this has been declining. And in 2016, it contributed to 24.4% of the country's GDP. Well, amongst this contribution to the GDP, crop production is the most important sector, and it contributes 89% of the GDP of this country from the agri sector, and it employs 60% of the population. This is just an approximation, but in some literature, you find that it employs up to 7% of the population. So the impacts of this changing climate on this Nigerian agriculture, it has been shown that 30% drop or decrease in crop output was recorded due to erratic rainfall. And this was in some years back within this 2000 to 2010. Then the agricultural forestry land use sector also accounted for 66% of greenhouse gas emissions. And this is the total greenhouse gas emissions that has been aggregated in the national greenhouse gas inventory of this country. And when this inventory was made, it has really shown that though the energy sector is contributing and the industrial sector is not much because of the very poor industrialization. And this was done in the 2015, this estimation. But it's so amazing that it was the forestry decline that accounted for most of the emissions in the Afolu sector, which even surpassed that from the energy sector. So the forests are declining by 48% from 1990 to 2010. And this has projected to continue at a very amazing rate, where some models even predicted almost no forest by the year 2100. And if mitigation measures are not taken into consideration, it's going to be very disastrous to the nation. So the Nigerian greenhouse gas emission also increased by 25% from 1990 to 2014, when this is when the initial estimation or inventory was taken. And mostly this emission, like I said, was accounted from the Afolu sector. So this shows how serious the agricultural system is in the current trend of practices. And if measures are not taken, then there is this greenhouse gas emissions will continue, and the impact on global climate change will also continue to rise. The good thing is most of these emissions, apart from the deforestation aspect, because in the deforestation that accounts for the 48%, but livestock sector or livestock production is also a sector that contributes greatly to greenhouse gas emissions, mainly from poor manure management and enteric fermentation. So if these systems are improved, then we will find a significant reduction in the greenhouse gas emissions. Although a 5% of these emissions, I think up to 13% of these emissions from the agricultural sector was from the use of fertilizer from the rice production systems that are currently being taken on. So other impacts that we'll see, apart from the decline in the decline in outputs, can also be attributed to the weeds, pests, and diseases infestation. Because when you have changes in the weather parameters, like the relative humidity, the rainfall, and increases in temperature, you find that there's some levels of infestation of these pests that you find in your field. So while crops are expected to respond to increased CO2 levels in the soils, in the atmosphere, with strong vegetative growth, because CO2 is going to be abundant in the atmosphere for photosynthesis. And this has been shown that it can increase vegetative growth in crops. Weeds will become more prolific in that reservoir, and are expected to invade new habitats as global warming continues. So this is now an indirect impact instead of impact on crop production. And then studies have also shown that herbicides become less effective in higher carbon dioxide environment. So meaning that the higher rates of herbicides will be required to be able to control. And we see that this is now going to give a very negative impact to the environment by exposing the soils to so many of these unwanted chemical herbicides that we use, and some of them have been shown to even lead to cancerous effects on human health. So this is also something that is very serious. It's an impact of increasing CO2 levels in the atmosphere. So insect pests of which carry plant diseases also become more prolific. When you have small droughts, I think there are dry spells, I will discuss them later. We also have these insects becoming very prolific. They become very, you find them in abundance.
Hello. Okay. Yeah, maybe I think yeah, we lost her. So she will again connect because of maybe the connectivity issue. So we have to wait for that till that time. Maybe we can discuss if you want to discuss something like what she was talking about, the impact so far maybe on the environment. And yes, he is going to tackle about how to handle that. But one thing was a very interesting. If we see the impact of a herbicide is reducing. So if we see in agronomy or in crop production, so weed management is really an important area. And if you are not managing well our weed, then maybe you are going to have such a kind of a means crop damage, because you are aware if you can manage your wheat with somehow critical crop weed competition period, then your yield losses are less. But if you are not able to manage well that part of your crop growing, then there is a chances you can.
Sorry, I ran into a
Yeah,
little
you are
technical
back. So
problem.
that's how I was just talking about the one issue you shared about uh, how the herbicide impact is reducing.
All right.
So its
All right.
effectiveness. So I was just engaging them. So maybe you can just take
Okay.
it forward. Yeah,
Okay, that's very good. Thank you for that.
yeah.
I think that is one problem with uh, with the virtual meetings that we still have to overcome, because the network sometimes keeps swinging. So I'm sorry for that little hitch. To continue from there, so the impact of climate change on crops at local levels will continue. That the length of rainy seasons can also be implicating. It impacts on the crop production. For example, last year in around our place here in Zaria, we had a very extended rainy season, and there is also areas, or there is also issues of the difference between rainfall onset and the cessation. And it is more important than the total annual rainfall is determining crop growth and productivity. So what we see sometimes, the rain doesn't start early, And then sometimes the rain also doesn't set, it also ceases early. Sometimes it starts late and ceases late. And these all have implication on the crop calendar, because there is a need for you to plant at a certain period of time so that you can be able to, for the crop to be able to produce throughout the rainy season. But on the other hand, if you have these differences in the time where the rainfall will set and the time where the rainfall will cease, then this is a problem. Sometimes the rainfall ceases when the crop is even at the vegetative stage. I think this happened in the year 2000 and I think 9 or so, 2009. The rain ceased early and it affected a lot of crops. Then last year, 2019, see exactly 10 years after, then the rain extended. And I'll show you in the few slides to come just one example of one of the things that happened. Even the cover page, you can see a soybean is in a logged field. That's the cover slide of this presentation. I showed a soybean in a waterlogged field, and that soybean is already in the reproductive stage where it does not need to have a lot of moisture. So because of these impacts at these levels, you see farmers shifting their crops. If the temperature is rising and it is the wheat crops cannot cope, you see farmers going into corn or maize. And then if it is not conducive, you see farmers also moving to rice. And sometimes farmers are into corn, but because of the duration of the rainy season may be short at that time, and they now move to sorghum or they move into millet. And these are all happening because of the changes in the climate. And then from some authors, Agbola and Ojeleye in 2007, they indicated reduced yields in the Ibadan. They used a model to simulate what the crop, they got the crops yields, and they used a model to simulate using the rainfall data for 30 years to see what impact is going to have on the crop output. And they found out that increasing temperatures, which are the scenarios they set for the models, that increasing temperatures and reducing rainfall had a significant impact on the crop yield by reducing the amount. And another author, or other authors, Agba et al., also showed that rainfall, carbon dioxide levels and high temperatures also affect crop output in Nigeria when they use data from 1980 to 2013. So this work, there are also others which we don't have to mention all of them, but all this work showed that climate change has an impact on crop production even at very local levels, which is at local levels of a community, at local levels of a state or a town. So this just to show you a little bit of an anomaly that was experienced in the rainfall of Samaru last year, where in last 2 years, where in 2019, we had these rainfalls along these dates. The rain started around the 10th of, the 1st to 10th of May, which is the first 10 days of May, and it ended around 21 to 31st of 21 to 31st of October. And this now showed that, sorry, this now you can see the rainfall amounts around those days are high when you measure them across in millimeters. And then you can see that the average from 1963 to 2012, the rainfall the rainfall experience in 2019 was much higher. You can see this bar here around, even the rainy days was very rainy. So we experienced a lot of moisture around that time, and a lot of crops were lost, especially soybean, sorghum, and the maize crops were actually affected. Even the cowpea was affected in that period. So and some of the weather changes we also experience. Sometimes you have dry spell early in the season. When the rainfall just starts, then you used to have some dry spell that it will just break. You can have a few days, sometimes extend to 2 weeks of no rainfall. And during this time of deficit, it affects the crop significantly, and you find a lot of those pest infestation we talked about in the previous slides. You saw a lot of pest infestation around that time, and if they are not properly controlled, it quickly destroys the crop at the beginning. Then sometimes mid-season also spells occur around June, July. But at that time, some of the crops have started grain filling. But in some cases, the crops have not started grain filling, but they are at the stage that they can cope. They are at the vegetative stage that they can cope with the little spell. But when these spells occur, when the crop is already at grain filling, then it significantly impacts on the overall crop yield. So now we move also to the other business of the day. So we have seen how climate change occurs, and what impact it has globally, and then what impact it also has locally when we consider Nigeria as, at our local sphere. And we have seen that climate change is real, it's occurring, and that was what made the commitment of the federal government. I think this current administration, President Muhammadu Buhari, signed into the treaty after the Paris Convention in 2015, that the country has to enter into the treaty of reducing emissions. And that was the intended nationally determined contributions. And they set a different set of scenarios where some key parameters were looked at, which are the reduction in gas flaring, going to more sustainable energy, into transport, reducing the burden of the transport system on greenhouse gas emissions, and also reducing the impact from agriculture, which is more of afforestation, and also using the climate smart agricultural strategy. So of course, one way to manage in this area where in the times of changing climate, you need to either adapt to the situation, and that is how to manage it, and then you can also go into the mitigation. So climate smart agriculture involves the sustainable increase in crop production and income of farmers, as well as trying to adapt and build resilience to the changing climate, and also to reduce or to remove the greenhouse gas emissions. So these are the three pillars in which the climate smart agriculture evolves. When you talked about increased or sustainable increase in crop production and income, it means that one has to adapt to good practices that will increase production of that crop. It can be in sustainable intensification, adopting measures that will increase production, user integrated nutrient management. It can be improved cropping systems that can all increase the overall output of the crop production, system and increase the yield and income. Then another way is to adapt and build resilience. Now the climate has changed. For example, the temperatures have increased. And what do? So in order to adapt, first you need also to get the good weather information system. The weather information system from our own local context, which is Nigeria. We can rely on Nigerian meteorological services, which is the NIMET, and then get information. And the good thing is that at any time there is going to be the cropping season comes, NIMET always gives a pre-season workshop and releases the annual rainfall predictions. And from that bulletin and workshop, farmers from different parts of the country are able to know when the rain starts and when to adequately plan the cropping calendar. So when you know that the rainfall is going to be extended, for example, like the 2019 scenario I showed you, then one can now decide, okay, if I live in Samaru and I want to cultivate my maize, then first and foremost, I need to know the maize variety. Do I go for the long maturing variety or the medium maturing variety? Because in this case, you can't go for the short maturing. If you go for the short maturing variety, hello, can you hear me? Hello?
Yes, we can hear you.
Yes, we can hear you, ma. Continue. We are with you.
Some of you need to mute your mic so that we can continue. Yes. So you need to know which varieties of maize to grow. In fact, you can even plan, okay, if I have this extended rainfall and I plant in May and the crop, the season even goes to the very end of October, I can plant 2 successive short maturing varieties. In that way, I can have 2 crop cycles within the season, even though it means you need to harvest and dry your grain in a different, because you will not expect it to dry on the field. Then you can also decide which crop, when to plant, so that if you are planting a medium maturing variety, you can wait to plant in June, so that it can go all the way down to October, June, or even July, if you know the calendar. So these are the kind of decisions that you need to take to adapt. So it depends on what is happening. Then there are also periods where you can have droughts. Like I told you the other year, if I remember, it was 2009, 2008 or 2009. I knew I was doing some field work then. And then the rain now stopped early. It ceased, I think, very mid or early part of September. And I was doing some work in Kano. I think just around that time, the rain just stopped. So if one has a pre-hand information of how the length of the rainy season is going to be, then you can decide to say, okay, I'm going to plant a short maturing variety. But it also depends on when the rainfall sets. If the rainfall sets early, and then you can quickly plant early so that you can meet the complete crop cycle before this rainfall stops. Other ways is also to engage in conservation agricultural practices. Conservation agriculture, which conserves soil moisture, which restores soil carbon, which reduces greenhouse gas, which also indirectly or directly reduces greenhouse gas emissions, can also be adopted. We are having some crop covers. You have a way where some cover crops will shield the soil from excessive moisture loss. This now we are talking about areas where there may be dryness, or the rain is not going to be very much, and you need to be preserving some moisture in the soil so that the crop can take it and utilize it to maturity. So all the conservation practices where you make sure that you build up some soil carbon or soil organic matter, leave some residues on the crop, on the field, are all those things that you can do to build resilience and to adapt to a changing climate. Then you can also do practices that will reduce or remove greenhouse gases from the atmosphere. For example, this is now a mitigative measure. They are all pillars under climate smart agriculture. So we mentioned that the loss of the forest covers a lot of losses, lead to the increase in emissions when the national greenhouse gas inventory was taken. So there is the need to take measures into doing some form of agroforestry, increasing forest cover. At the same time, you have some agriculture going on below these systems. They are very efficient system of agroforestry. I know that exists, and some people are utilizing them, and some are yet to know so that they can maximize them. Then there are also practices like use of low release fertilizers. When you use urea in granular forms, you call them USG, urea super granules, you tend to reduce the release of nitrogen to the soil. And you know, nitrogen is easily lost, either volatilizes in the atmosphere or lost as leaching, or even lost as nitrous oxide. So instead of having these losses, when you use slow release fertilizers and or slow release forms of urea, some are coated, some are uncoated, but because of the sizes of the reduced surface area, the fertilizers are always available to the crop, and there is a lower level of losses to the atmosphere. Then when you also do some practices, this is now placement method. I don't want to go into the 4 R's. Maybe some of you are already aware of those ones, but they all increase nutrient use efficiency, and we'll see them in the next slide. So urea deep placement is UDP. So in a work done by International Rice Research Institute together with IFDC, the National Fertilizer Development Company, IFDC, they found out that 40% of the N published, I think just 2021 in January, this January, the Hakawa also et al. And these scientists also reported that using crop rotation, using rice in rotation with wheat and soybean with other upland crops, compared to continuous rice, which is continuous cultivation of rice under flooding, continuous flooding, was also found to reduce the greenhouse gas emissions by up to 23 to 40%. So there are to place these mitigation strategies into 2 broad categories. You can have it where there is better resource use, which is resource use efficiency. This now is the sources of most of the greenhouse gases, so that when you have these efficiencies increased or improved, you have less of greenhouse gas emissions. And one of these efficiencies is water use efficiency. I mentioned earlier, if you are using irrigation and you are controlling the amount of water, not letting the crop to be submerged in water all the time, you are reducing the water, which is a non-renewable resource. At the same time, you are also safeguarding the environment from losses as leaching or losses as nitrous oxide. And then you also have NUE, which is nutrient use efficiency. So you manage more of your nutrient. The crop is able to utilize the nutrient that is in the soil and use it for growth, and you get more yield. And also land use efficiency. Land use efficiency where you don't allow, for example, when we are doing our cropping, we are having a good practice of spacing. If you have good spacing, rather than putting the crop from one point here and you walk a distance to another point, and then you see a lot of gaps in the field, then you are not utilizing the land that you are using to grow. So you have to efficiently do that by also planting and spacing carefully, so that you have a better yield. And then you also practices that avoid residue burning, so that residues are burnt, they return gases to the atmosphere, which will further increase greenhouse gas emissions. At the same time, you also have manure loss. I just lost my lights. So you also have situation where the manure is not managed very well, and a lot of losses occur from the poor manure management. So there are also one area that is also found to be a significant sink for greenhouse gases is the soil. So if the soil is catered for very well, I'm a soil scientist, maybe I'm not being very biased by saying that, but I know that the soil is a very significant sink to carbon, atmospheric CO2. So soil carbon sequestration can also be used to be able to be a source of sink for the high carbon dioxide that is in the atmosphere. And then we'll also do practices that avoid land degradation, and then improve on afforestation programs and reforestation programs, and reduce deforestation, and then taking care of conventional best practices that include increased soil C. One of these practices is addition of organic matter, or the use of biochar and compost, all best practices. So continuing on ways to manage, I mentioned earlier that it's good to have access to good weather information, so that you plan your cropping calendar appropriately. And with this, accurate weather forecasts and predictions will be possible, and this will help to prevent weather-related disasters through early warning systems and effective response and systems. So if you have access to weather information or weather station, that this will improve this forecasting. And with decreasing rainfall amount and duration, frequent droughts and desertification, drought resistance or short duration high yielding crop varieties should be developed and made available to farmers. These are all ways that you manage, and these crop varieties, like I mentioned, are already available in places. Like in our own institute, we have different varieties of maize and of cowpea, of granule, that are able to withstand some of these stress, drought tolerance, disease, and disease resistant, or striga, or weed tolerant. We all have this variety. So when you have information on these varieties that can be used to adapt to a changing climate, then that is also good. And then Nigeria should start to invest heavily on irrigation farming, rather than relying more on the rainfall that is highly unreliable and becoming more unpredictable and becoming more erratic, rather not unreliable. The rainfall is becoming erratic, and we experienced a flooding, I think 2020 last year. Some rice farmers, especially in Kebbi State, lost significantly a large portion of their farms, most of them, including those that are under the CBN and Ankupura programs. So in this case, you can all manage these losses by going into irrigated farming. Irrigated farming is more expensive because there is you need to invest in pumping the water, unlike rainfed that you rely on the rains to grow your crops. This involves investment in irrigation and other pest control measures. So, but it's also a way to manage or to cope with the changing climate. Then, in this case, there is also the need for insurance. Crop insurance is so that not farmers don't lose a lot from what they put on the field. Climate finances is available, and most of the burden, up to 22% of the economic impact, is being absorbed by agriculture due to natural hazards, and part of it is what I mentioned on the rice farmers that that got their lands flooded last year in 2020. So farmers should be able to get access to these climate funds, so that they can be able to cope with the natural hazards that they can't have any control over. So this is a picture of a very interesting picture of the extended 2019 rainy season. You can see here the maize were already harvested, and they were already cut into this stack that is a practice by farmers around our own local areas. So you can see that the maize, these farmers, most of them lost this maize because it continued to rain even after they cut the conclusion part, so that we can also take some questions and more comments. There is a need to embrace good agricultural practices as adaptation and mitigation option. I mentioned the different climate smart concepts and the practices that can be embraced to be able to manage effectively. And I also mentioned that there is a need for improved cropping methods or cropping systems, where the best methods that exist to utilize your resources, for example, your fertilizer resources, your water resources, need to be adopted so that you can have a good way to good yield, to be able to reduce some of the impacts of the changing climate. And there's also the need to incentivize CSA. So here, if people are to be encouraged to take into cognizance those best practices, there is a need to be some little incentives in that regard, so that it can help them to adopt the practices. There need to be more awareness and trainings, and then the adoption. And if these are not taken into cognizance, then there will still be some problems. But it's a very good thing that Indorama is organizing this workshop, at least this talk that we had this afternoon. I'm sure most of you know, I know most of you know to some extent what I said, but you also have increased knowledge of what needs to be done. And as people that are practicing agriculture or crop production, you can be able to scale down this information to your farmers that you are working with, and then get having built your knowledge. And then also the aspect of climate finances, these are also existing, and there is a need for the country to be able to access these funds, because these funds can be used for what I mentioned in incentivizing CSA, in the ensuring farmers, in getting farmers in getting farmers to have access to weather information. If this weather information is not readily available, then it is a very good way to access these funds to be able to make farmers to have that. And these funds can also be used to go into a kind of e-extension kind of a thing, where farmers can be, or a group of farmers can be assisted with maybe all these new ways of information and technology dissemination, when they have a tablet and they can be used to get access to information, to get access to weather data or weather forecasting. All these early warning systems, they can be used without farmers even going to the field directly, because now things are changing with the COVID, with this pandemic, and with some sort of insecurity that is ravaging our society or the nation. In these climate finances can all be used to further see that this climate change impact is greatly reduced. So I think I talked for almost an hour. I'm supposed to talk for an hour, but I have concluded this presentation now. So
Okay, thank you very much, Dr. Aisha, for a wonderful presentation.
Yes.
In the absence of Dr. Pravi, I'll be heading the section now. So, is there any agronomists that have questions? Let's make it orderly. You have question, you just raise up your hand and then I'll call you. Okay, let's start with Abdulkadir Umar. You can go ahead and ask a question.
Umar from Funtua headquarters, Katsina State, agronomist. Thank you, Prof, for this wonderful presentation. In fact, your presentation has made my day. We really appreciate this. Before I lay down my question, I just want to tell Prof, most of these things you highlighted, we are really delighted. It has really improved us. And this shows that Indorama agronomic activities is in line with reducing or mitigating the effect of climate change. Because the aspect of crop management, good agronomic practices, and all what you highlighted is what we are always doing with farmers. Thank you very much. My question is on I need more clarification on the issue of herbicide you highlighted initially. You said the impact of herbicides is reducing. I don't know. Reducing, is it in the aspect of resistance by insects, or resistance by the crop, by weeds, or the use of herbicide is supposed to increase? I just really need clarification there, ma. Thank you very much.
So any other question? Do you want me to respond? Do you want me to respond as it is being asked, or to wait all the?
I think that would be better. Once the question is asked, you respond, then the next person asks his question.
Okay. So what I said about the incidence of the herbicide is that when there is increased level of CO2 in the atmosphere, you also find different different herbs or weeds competing to also, because they are utilizing the CO2 for photosynthesis. And then you have also a prolific growth, just like the crop will utilize the CO2 to grow and produce food. Then you have a situation where the crop is, or the weed is also doing that. And as a result, you find a kind of, the herbicide you are applying is not very efficient, and you need to apply more and more and more because there is prolific growth of weed. So this is part of that issue. So much so that this increased CO2 level is now having like a kind of a negative effect indirectly, though for crop growth is good, but because it enhances the proliferation of different weeds and different weed species, then it now becomes a problem, and you need to apply more and more of the herbicide before it becomes effective. Right?
Yes.
Yeah. Then in terms of also the diseases, or let's say the pests that are also available, when the you have periods of dry spells or periods where the temperature rises when the crop is growing, you also have increased incidences of pests. Take for example, if you grow maize and there is a dry spell of 5 days or even up to 10 days, you will see a lot of insects flying around in the field, and most of them will be ravaging on your crops if you don't control it. So that in that case, you may need to even increase the frequency of applying the pesticide for you to be able to control this. So these are all impacts of climate change that we are witnessing in the field. I hope it's clear.
It's very clear. Really appreciate it.
Thank you.
Thank you.
All right.
Magaji, you can go ahead with your question.
Thank you very much, Prof. This is Magaji Auta, Emmanuel Zaria headquarter. My question is that is here. You said we have to reduce the use of nitrogen fertilizer at least by 40%. The company is happy when we sell more of fertilizer, but at the same time, it's affecting crop protection or keep on degrading the soil. How do we get a strike balance, since we want to sell and we want to farmers to apply more, but yet it has an effect? So in what way can we strike a balance so that both the two sides may not be affected negatively? Then again, I don't understand the soil we are using, the fertilizer we are using. In those days, and as I grew up, we don't apply nitrogen but fertilizer in leguminous crops such as granite, soybean, and beans. But now, if you apply it, if you didn't apply to your crops, you will not get anything. What is actually happening? Are we now saying the relationship between the nitrogen bacteria in the soil, nitrosomonas, are not more in the soil, or actually what is really happening? Then the last question is that I tend to confuse. Right from undergraduate, we've been told that most especially the cereals belongs to family gramineae, that is the grasses. So why do grasses have much negative impact to most of the maize? Is a maize is a graminea too. Why is it that it cannot thrive very well in the soil as the grasses thrive? That you have to pay much attention in removing the grass before you can even get a little yield on maize, since they are of the same family. Thank you very much.
Okay, thank you, Magaji. Yes, to respond to your comments, you see, there has been a kind of evolution, because
Okay.
before the farming practice it was like they went before the discovery of urea, for example. Before the discovery of urea, the farmers are just using maybe their manures to grow crops with a lot of for now we call them sustainable systems. Then the urea now was discovered, and a lot of farmers now went into use of chemical mineral fertilizers, and they were seeing significant yield, significant changes in their crop production. But over time, because of one, misuse, that's why we talked about the 4 R's. You can still use fertilizer, but when you use it efficiently, the way you have to use it, like I mentioned, nutrient use efficiently or fertilizer use efficiently. So when you use it according to the way it's supposed to be used, then you may not be having this negative impact. So, and the reality, the truth is, as much as we advocate for soil health, sustainable systems, we also tell farmers that they should go into integrated nutrient fertility management, where you apply both form of organic and inorganic. The organic aspect is still keeping your soil alive. I'm a very proactive advocate for that. But at the same time, all our soil, most of our soils, in fact, since from 1973 that analysis has been made in savanna soils are low in total nitrogen. All of them, even recently from an analysis that we conducted in some northwestern states of Nigeria. When students come, all their analysis of total nitrogen in the soil is low. And how do you grow maize in these soils that have low nitrogen? And then when the organic resources are not enough, if you need to apply only organic or go into only organic production, you need to apply a lot of organic material, which is not available. And the practice here is that most of the farmers take away the residues from the soil. So they take away crop residues that may be able to add some back, some organic fertility back to the soil or replenish the soil with some organic resources. But this is not done. So as much as we want to say yes or no, we have to use mineral fertilizer, but we have to use it in the right way. And that's why we have the 4 R's. I'm sure you know the 4 R's. Applying the right source,
right time,
at the right time,
quantity,
at the right quantity, and at the right place. Yes. Placement method. So if you do it that, you are also doing that climate smart agriculture that I mentioned in my presentation. It's part of the 4R. And what we said about the fertilizer, is not the fertilizer that is being reduced by 40%. No, the fertilizer losses were reduced, what I mentioned in the presentation. The end loss was by 40% when it was applied using UDP method, using the urea deep placement. So which means it is now part of the R's, the placement method. Now it is fulfilling that part, where there is 40% reduction in the loss, because more if you apply on the surface, the fertilizer will be lost to the atmosphere as to be volatilized as ammonia. So that is also a kind of the loss. So the other question you mentioned about the leguminous crops that people are applying fertilizer. You see, when you don't have appropriate extension or to tell farmers will think that just like they apply maize and getting a result, we are applying fertilizer to maize and getting output. They think they will also apply to anything green and they will get an output, not knowing that they are losing it. Now the R also, the 4Rs also now will play a role in the legumes. Legumes don't need a lot of nitrogen, but sometimes a 20% nitrogen is applied, 20 kg, we apply 20 kg of nitrogen to cowpea and up to 40 kg of nitrogen to soybean. But that is mostly to enhance the microbial, to stimulate the microbial population to start to work in the soil, to stimulate mineralization, the breakdown of organic matter. So this is all like that is why sometimes it is being put. And And it also helps in facilitating at the beginning, before the crop starts utilizing the nitrogen that it produces itself, before it starts producing nitrogen in the rhizosphere or in the root zone, the rhizobium, before it starts working to produce nitrogen. That is why we need to stimulate it with a little boost of nitrogen fertilizer. But they need more of phosphorus. Phosphorus
Okay.
is required for nitrogen fixation. So mineral fertilizer, if it is not used properly, not the 4 R's not taking place, then the people are not doing what they are supposed to do. And when you said that before, mineral fertilizers are not being used for cropping, for legume crop, it's because that time there has not been depletion. But when you are having continuous cultivation over time, you're having depletion and you are not having good system to replenish, then you need to add the fertilizers. There's no way you do that. So that's the issue. And then for the cereal crops or the grass competing, see, now this is now going to physiology of crops, because you have the C4 and C3, C4 plants. And then mostly the nitrogen, the Gramineaceae or so, let's say the cereal family, they are heavy end users. So when you have different species of those kind of cereals, they also have different ability to compete. Maybe I cannot compete. You may have a body size. I'm a human being, you're a human being, but your body size makes me not compete as big as you. So these grasses, sometimes they have more competitive ability to absorb that nitrogen before than maize. So you find that they are very noxious because they are trying to survive. You are trying to eradicate them. Anything that you are trying to eradicate, it starts to survive. So it's a part of that survival strategy. Part of that competitiveness in the ecological system is what makes the grasses to continue to strive beyond their other brother maize. So this is part of the logical explanation I can give, but we can look at it more. Yes.
Thank you, Prof.
Are you satisfied?
Yes,
Magaji?
I'm okay. Thank you very much.
Mr. Magaji, good afternoon, ma'am.
Just a moment. Aisha, we also like to share here with you that our company is targeting a product which helps in minimizing these losses. So we are already our product trial product is in research field. Even one of the trial is in your university itself. Professor Ado is taking care for that. And yeah, soon we are going to come up with a product, because we also understand these kind of a climate change issues and minimizing the losses of these kind of urea, means nitrogenous fertilizer. So we are in the process of launching at least one or two different products which enhance the nutrient use efficiency of our urea.
Good.
So
good.
Yeah, that is on the ground, and soon the moment we'll get a government approval, we'll just start marketing also.
That's very good.
Just for the information.
Now, okay, thank you very much. Thank you.
Good afternoon, ma'am. Hello, can you hear me?
Yes, good afternoon. I can hear you.
Okay, yeah, thank you very much. Yes. To add to what Magaji asked about the third question about why cereals are not as hardy as before. Yes, what you said is very quite right. You talked about the physiological aspect of crops. Also, from the breeding perspective, Magaji, you understand that because breeders do selective breeding, when they are selecting, they select for particular traits that favors them. Over time, what we select for creates a bias. For instance, you are selecting for yield. It will not be as it was when you selected from the very beginning. When you do crosses specifically for a particular thing that you're looking for. And it means that you are going to shed some things. Whenever you do crosses, you gain some and you lose some. So over time, because we are looking for yield most of the time, we are looking for resistance most of the time to a particular thing, depending on our breeding program, we tend to, as breeders, let some things go. So most time hardiness are let go. For instance, in this series, hardiness are let go. So if you go back to the original germplasms of maize, you find out that the origins, those ones that were selected from the very beginning, they have the ability to compete, but the yield may not be what you like. I don't know if I'm right, man, but over time in breeding, that's what breeders do. They select, and when you start to select, it's like taking a cub from a lion's den to domesticate. Over time, after some years, when you return that particular cub to that lion's den, it will not have the ability to hunt, to get its own food. It will not have that instinct to quickly adapt to that natural environment which it was taken from the beginning. So it will lose its hardiness. Meanwhile, you have gained the docility in making the animal a pet, kind of. Thank you.
Yes, thank you very much, Osamude. I think this is very, very,
Yeah,
very
Osas is okay.
yes.
Osas is okay.
It's very okay. So any other question or comment, and anybody that wants to contribute, maybe there are some things I missed out. Or
yes, ma'am. Good evening.
Hello.
Good afternoon.
Hello.
This is
good
Anas
afternoon.
This is Anas from Sokoto Bodinga headquarters.
Okay.
This is a nice and wonderful presentation you did. And we can all notice this climate change is seriously impacting agriculture. As last year, this definitely happened in Sokoto, that during the time of harvest, rain did not cease. It continued doing it. The rain was continuous up to November. I still experiencing it, which causes a lot of loss of yield. Even the millet has to be turning black. Secondly, we experiences flooding. And thirdly, even the cold, they did not set up on time. As even currently, we are now experiencing cold. So which affect wheat farmers seriously. So my question here is that NIMED used to give all this data to before season, how the rain is going to happen, when it's going to start, and when it's going to end. My question here is that these farmers, a lot of them don't have access to this data. One, and even if they have access to this data, they might not be literate enough to decode the data. So what are the easiest way or simplest way that you can be able to tell farmers how to control or how to change their farming? The easiest way or steps to follow in telling them how to embrace this change of climate change. Thank you.
All right. Yes, thank you, Anas, for this observation. You see, when you are working in different systems, you learn that different organizations have different mandates. For example, in the Institute for Agricultural Research may have mandates in some states and for some crops, but because of maybe the collaboration they are having, for example, collaboration with NIMED, maybe they can have a little mandate on disseminating climate information. But the primary mandate for dissemination is the NIMED. Although during this annual prediction, they call all stakeholders, both all the research institutes. I know my research institute used to be there to represent them. And for 2000, I know for 2020 and even 2019 or so, our institute used to release a kind of bulletin, you call it, or a guide, that this is the time, the right time for farmers to plant maize. He used to release a calendar for people to be able to plant maize, for people to be able to plant other crops. So the medium that was used, which I know reached most farmers last year, was both radio and newspaper. So if you broaden the medium to reach the farmers, okay, maybe the farmers are not literate to read newspapers. So, but other radio programs that can be aired in the local languages, which is, for example, in Hausa, in the different states that we have around. If it is a state where they speak full day, then they can be aired in different languages that the local farmers in that state can understand. So maybe this needs to be strengthened, but I know that to a large extent we do it, but it needs to be strengthened. And part of this climate finances I mentioned will be able to handle the cost or the fund of some of these things that we are saying, dissemination of local weather information. And I also said, if these farmers can form groups, and their groups are empowered with, for example, tablets that they can be able to handle and access some of this climate information directly. There can even be a system where, with collaboration with the Nigerian Communication Commission, farmers can be receiving SMS alert in their local languages that they can just see. Fit an alert will just come in. Most farmers have mobile phones. Even if these mobile phones are not Android, but they can be able to receive short message services. And if this can be expanded, I'm sure Anas, you can agree with me, but it is something that requires some funding to be able to
Yes,
do that.
even last year we tried the same thing. We were sending text to farmers using in collaboration with one Iska weather. They are receiving like today is going to be rain, and the next day is not going to be rain. We even try in all our effort to improve agriculture. We even tried that with farmers last year.
Yeah, so if nationally this can be expanded nationally so that it can be linked to the Nigerian Communication Services to fund. Now that you sending farmers information, you are using your money and your phone. Though it worked, but it's also, you see that a lot of fund or cost implication to that. So if some of these finances can be able to handle this kind of aspects of information dissemination, early warning system, weather forecasting, for farmers to be able to plan appropriately. Even the cropping calendar can be sent to them. You can, if you are planting this kind of maize, you can start planting in this date, day 1, day 2, day 3, or this week, this window. You know, a window period can be given so that these farmers can can plant those crops along that cropping window. So I agree with you, but it's something that needs some funding, and I think part of the climate funding can be used to improve this weather forecasting system. Thank you.
Yes, but ma'am, my serious problem is this dry spell. It started to become a trend. It happened in 2018, 2019, and even currently 2020.
Yes.
Yeah. How can farmers handle that? Because mostly how it happens, it is when the crop is at vegetative stage before it enter reproductive stage, the rain used to just cease like that.
So see,
how can we handle this problem?
Yes, last year I also gave a webinar on the use of getting information. And we are just trying to give the webinar to media practitioners so that the media practitioner can use their talent in media to disseminate to farmers. And one of the things that is very crucial, now I'm going to talk to you as a soil scientist, is if you adopt good soil conservation measures. For example, you have a soil at that time that has a little cover, or it has a lot of organic matter that can absorb some of this moisture and hold it for some time. Then this crop can be utilizing some of this residual water as it grows. I know it's in the vegetative stage, and it used to occur when the crop is strong enough to handle some of these stresses. It happened on my farm. I was worried, but then when the rain fell, they all picked up. Some were collapsing, but some of them will pick up. And as a civil, it has ability to tiller. You can see a little tiller, a new tiller growing by the side, and somehow it compensates for the main stem. So if you are doing all these best practices, I mentioned it inside the presentation, good soil conservation measures, those conservation measures that will increase soil organic matter are all required. And this is now going back to that integrated nutrient management that I mentioned, using of conservation agriculture, using crop covers or crop residues, not burning residues and leaving them. They all help to improve the ability of the soil to absorb moisture. It's like a sponge. You leave something that like a sponge that will hold absorb the moisture. Then when the moisture is not available, then it will be releasing it a little bit and bit and bit. So if you adopt a measure of using a residue, let's say mulch or crop residue around your crop stands, then you can be able to conserve those moisture, because the residue will not allow the evaporation to go on. At the same time, it will hold some of the moisture within the soil. So this is more of soil conservation practice that maybe farmers need to know with time. And I know people in the areas like Burkina Faso, Mali, that are doing the ZIA system, that are making planting pits and still putting a lot of organic manure around the pits. I've recorded successes in terms of moisture conservation. Yeah.
Yeah, it is. Sorry, just a moment. It is really a good to hear that your organization and you were contributing a lot for mitigating or efficiently managing these type of a climate change impact. I have just a suggestion and idea. If you just feel like it is good enough, we can adopt immediately. So we have around 56 agronomists working in field, and our reach to the farmer is of around 3 to 4 million farmers. So our urea is just reaching to that number of a farmer. So if we can create a one small WhatsApp group, including these agronomists and yourself or whoever is responsible in your department, for just disseminating that information, what you are using for the radio and all, if you can just put that information on that group, these are the guys who are interacting with the farmers, and they can just disseminate that knowledge and requirement to the farmer. And if you are willing to, means okay with that, I can ask one of the team member to coordinate with you and create that WhatsApp group.
No problem. I don't think it's a problem, because why we are working for farmers. There's no point we have a knowledge and we keep to ourselves. There's no point. Okay. And as much as possible, we want our technologies, our information to go as far and wide. And one of the limitations that agriculture is suffering in Nigeria is the low or the extension farmer ratio is very wide. You know, the extension department is still, I don't know how to call it. It was almost dead at some point, but now they are trying to get up. But they don't have the capacity to reach the many farmers that are around. So we try as much as possible in the little forum that we can. Even now, the e-extension is this one you are suggesting is a form of e-extension, so that using communication technology to extend information to farmers, because that is what has to even be done with what we have, the manpower we have on ground. And I mentioned earlier with the things like pandemics, like there is happening right now, with this of insecurity sometimes that is happening, you may not be on the field all the time. So using this kind of platform to send short messages for farmers, it's time to apply fertilizer, apply. It's time to do this, apply. So these are all forms of forum or media that can be used to disseminate this kind of information. So it's no problem. We can further discuss with one of your representatives. I will also inform the institute management of this initiative so that it goes.
That's great. So somebody will be in touch from our team. So Yakubu is waiting from a long time. So Yakubu, go ahead with your question.
Yes, thank you very much, Prof. Yes. For a good presentation. I want you to understand that yes, we are just working with the end users, and our end users here are farmers. And most of this information we are getting, we have to give them an information that is from a very reliable source. So going by this, since you are into Research Institute, you have been working with NIMED data for quite a long time. Please, can you share with us how reliable is this NIMED data? So that when we are communicating, yes, we know we are communicating a real information to the farmers. That's one. Then second dilemma, you are also heading a farming system. Please, though you dodged the question from Anas, how do you communicate this information to the farmers, Ma? We really need to adopt that because your institute is one of the reliable institutes in the country. And any information that comes from Institute of Agricultural Research, farmers normally adopt that. So please, you can share with us, how do you communicate all these information to your farmers? Thank you, Ma.
Okay, thank you very much, Yakubu. With respect to the reliability of NIMED data, yes, NIMED is working very well. And most weather organizations, or let's say weather forecasting organizations, are using predictive models. It just depends on how very reliable is their, or how very sensitive is their model. So there are very, very good or accurate models that exist, but I don't want to go into ideology, but sometimes no matter how we feel we can have some control of information on the weather, it's not really in our hands. We just try to use the knowledge of past or historical weather events and try to see how to project it into the future. So these predictions are actually based on what these models give them, and they are pretty quite reliable. I think they have very much improved models now. So the idea of how to be very, very sure that what NIMED is giving is true or not, we wanted to go into actually validating the NIMED predictions. For example, in terms of the length of the rainy season, so that we can see that once we develop a calendar based on those predictions, we also run some kind of a test in our own place, like let's say on station testing, so that we can be able to predict this. But there are still some logistics going on that we're not able to do that exactly, but we had that intention. But what we only rely on to disseminate to farmers is what we get from NIMED, so that we would advise farmers with what we got from NIMED. But we cannot say 100% that we have validated it before telling it. And continuously, if you say you continue to validate, though you can validate their model to see how very predictable it is for a particular region or particular agroecological zone in the country, then yeah, you need to do that validation, but you can't do it all the time. So, but we are working very hard to see that we work on that validation, because you can't keep validating if different models are coming out for all the time. So if we are very sure that what they have is for the very long term, then the validation is going to be done. But they use quite good models, and these models have also been tried. I think part of the models they use, one of them is the DSAT, I think, and they have been worked upon in different parts of the world, and they have been found to be able to predict some of the performance of crops when you take the planting date, for example, and considering the length of the growing season. So, but that is, we'll continue to do that. With respect to farming systems, yes, we have different research programs under the farming systems research, and we do some work on farm with farmers, and the extension unit of the institute is actually mandated to be able to disseminate all the technologies that we find are very good and reliable and so taken to the farmers. So directly the program cannot disseminate, but can do its best through the medium that they have, which is doing some on-farm work with farmers. And when you are doing some on-farm adaptive research, you are working with group of farmers, and you expect that within a cluster of farmers that you are doing the work or you are testing the technology, you are expecting that some of the farmers around are also able to absorb or understand those technology. So the current institute management is actually very concerned and focused on that aspect of extension, to see that research output and information from the institute reach very far and wide, not only within the mandate states of the institute, which is the northwestern state, but going beyond northeast and even south and southeast and southwest. So we are trying to see that we have that reach, and the university, the institute website is very vibrant, and a lot of information, extension information can be obtained there. While for those other farmers that may not have access to the institute, there are programs that have been set in place that will be able to reach all those technology, will be able to reach them directly on the field, using all the available methods or indigenous methods of disseminating information that we have. So I think I have told you some. You can always ask me after this forum. Dr. Praveen can link us up, and once we get discussion about the WhatsApp platform, that is now a very perfect way of accessing each other and passing information. Yeah.
Yeah, so definitely I'll ask my the team member who is operating in Zaria. He will be in touch with you, and he will create a separate WhatsApp group only for this climate change and just disseminating that knowledge. So yeah, it is a long time we are holding you back. So I'll take up the last question from Ibrahim, because he has raised his hand. So with that last question, we'll wind it up. So yeah, Ibrahim, go ahead.
Thank you, sir, for the opportunity for me to ask question, and thank you, Prof, for this wonderful and educative presentation. Mine is a concern. I'm Ibrahim, and I'm representing Indorama in Ikara local government, and Ikara is one of the areas that are producing largely in huge numbers maize, which is a common cereal here in this environment. So I have noticed something. The farmers are always scared. They're in rare scared that the problem we encountered with respect to fertilizers is going to set in again, meaning high prices of fertilizers, unavailability, and what have you. So this made the farmers to be pushed to be buying all sorts of fertilizers they see in the market. And among these fertilizers is this diammonium phosphate. And diammonium phosphate only supplies phosphorus and some little, yes. So my concern is, I don't know what's going to happen. I don't know. I have a fear that because considering potassium as a very essential element in producing maize, for example, the NPK, if farmers have continued buying DAP in large amount, stocking in preparing for wet season, what will be the possible implication of this kind of act in relation to
yes. Okay, are you done?
Yes, I'm done.
Okay, so thank you very much. You see, that's why when you are doing a kind of a program or study, you have to also consider the socio-economic aspect. There are some aspects of this, the farmers, this psychology, you say that you need to keep, it's very amazing because you have to keep trying to understand. But I don't think these farmers started buying DAP by chance. It's possible that there have been some projects that went on. It may not be only, it may not have gone on through my institute or this my institute, but I know there have been projects that have gone on. You know, there is a fertilizer department in the Ministry of Agri, and there are some people that are interested. There are different people that have interests in maybe fertilizer business also, and it's possible they have done their own work. But I know from some of the research I have come across that our soils, even part of the research I did, our soils are not so deficient in potassium. So much so that when you are talking about site-specific or crop-specific fertilizer recommendation, there are some places that potassium is not a problem, even if you don't add it. And adding it is just a waste, an extra waste of cost and extra waste to the environment. So probably these people are adding, they are using DAP because they have been told that they only need phosphorus and nitrogen, for example. So, but then when you also keep using DAP, we know the problems that will emanate. One of the problems is you have acidity building up, and then there also you can have P sorption. What you call P saturation is our soils also may have some moderate deficiencies of phosphorus, but phosphorus is not as mobile as nitrogen. So if you keep adding them in the soil, you have a buildup of phosphorus, and you call it P saturation. And that is also another problem, because when you have that soil at P, having a soil that is saturated with P, you may not also have some other vital elements that the crop needs, or macronutrients that the crop needs. You understand? So I don't know why they are doing that, but also advocating all the time for site-specific fertilizer recommendation or soil testing, so that when you are doing extension work there, you need to invest a little bit and do soil tests and tell them that no, these fertilizers that you are adding is not going to be sustainable because your soil is already saturated with P, and if you keep using DAP, you will not be able to even get what you want. So it has to be continuous. Even you as the marketing department, you have to engage in kind of some continuous work, not just to sell, but also do some kind of your own assessment of the situation on ground, do some socioeconomic assessment, do some soil testing so that you can give them advice that this is not working. You may not want to kill the market of those ones selling DAP, but you need to also strategize in how to market your own product to show them that this is what they need, because DAP doesn't have the complete nitrogen requirement of the crop, and it's also missing in another vital major element, which is potassium. So if potassium is not there in the soil and they are not adding, then you have to sell them another idea that DAP may not work. It may not be sustainable for them. So I think I tried to answer.
Yes, thank you.
Yeah,
All right.
so that's great. And I would like to bring in your notice two, three things further. As you are saying that doing a soil sampling and doing the soil analysis, we are already doing that job. We are doing a good number of a soil sample every year. We are using a soil kit that is a qualitative. Based on this requirement only, the management has decided to establish a wet chemistry lab. So within next 4 to 5 months, we are going to have our own wet chemistry lab, and that too is for the farmer, and we are doing these tests free of cost. We are not charging anything from the farm. So that is the one thing. That another initiative what companies is what I'm getting, that our initiatives are aligning that what you are suggesting, and then we are working on a area and crop specific micronutrient fortified urea.
Okay.
So yeah, definitely a P and K is there. So can we come up with a product which is going to have all the required micronutrients also? So our vision and thought process, we are going up to that level. So maybe we are going to give a area and crop specific micronutrient customized urea.
Okay.
So these are the these are some initiative we are on the part. Uh, yeah, it was a really enlightening session for us, and our team members has really enhanced their knowledge in the area, and yeah, we are going to take it forward for becoming a bridge between a research as well as the implementer, like the farmer. So definitely our team member is going to create that WhatsApp group, and we are expecting your technical support there. So yeah, we would like to convey our sincere thank on behalf of team as well as behalf of our agronomy team as well as from the Indorama company. So thank you very much for giving such a wonderful session for our technical team, and we will definitely take it forward to the ground to deliver the result and effort to our farmers. So thank you very much. Yeah, thank you, Aisha.
Yeah, thank you very much. Thank you all.
Thank
Have
you
a
very
nice
much.
evening.
Yes,
Bye-bye.
Bye-bye.
Bye-bye.